Hi students, welcome to our maths class, and today we will be starting in a series of lessons under the topic sets. So I hope you have your pens and your papers and you are ready to work. Are you ready to work?
Yes, sir.
All right. Now let us explore mathematics a little. We will be looking at the topic sets, but before we go into details with sets, I just want to remind you that y'all did sets in Form 1, right?
Yes, sir.
Good. So today's class will kind of be a refresher for the things that you did in first form, so that you will be able to master sets in second form. So what we will start by looking at is the symbols that we use in sets. Because you know, if we're going to write sets, well, then we need to know the notations and so on that we will use in sets. All right? Yes, so the first symbol we will look at is how do we write a set? How do we name a set? How do we name the set? Anyone can say how we name a set? All right, let me ask the question differently. Do we name the set using common letters or capital letters?
Capital letters.
Yes, we only name the set using capital letters. So we name the set using capital letters only. So for example, we may say that the set A is equal to something, all right? And we know that we list the sets in curly brackets. So for example, we may have A, B, C. We have the set A equal to A, B, C. So whenever we see A, we know that we are referring to a set, all right? You have a question? Okay, good. We don't have a question. So now that we name the set, the next question will come to mind. You know, there are things inside of a set. If you have a set of anything, for example, we have a set of students, well, then we have things inside of this set, right? And each thing in the set, there's a particular name for it. Yeah.
Elements.
Very good, very good. Elements, right? So the members of a set, we call the members of the set the elements of the set. All right? Yes, you say something?
Or members.
Yes, the members or the elements of the set, we call them, we refer to the things that make up the set. But there's a symbol that we use for this. I'm sure that you saw this symbol before. Have you seen this symbol before?
Yes, sir.
Good. This is a symbol. So you see, the thing in mathematics is that we try to use as little as possible. So rather than saying members of a set, we say elements. But then rather than saying elements, rather than writing out this whole word elements, we just use this letter here. Right? We just use this notation. So for example, we can say that for this set A, we can say that B is a member of the set A. But look how short that is written. Right? So we're using set notation here. Rather than writing out B is a member of the set A, we just write B, this symbol, A. So if somebody don't know mathematics and they look at what we do, they wouldn't understand. But I'm sure you understand what this is, right?
Yes, sir.
Good. So, for example, if I have C, can somebody please read this?
C is an element of A.
C is an element of the set A. Correct. But what about Z? Z is an element of that set?
Sir, but it's not in the set itself that is listed there.
Yeah, it is not in this set. What about P? Is P listed in this set?
No, sir.
So then if it is not a member of the set, you know, we need another symbol for that too. Right? It's not a member of the set. Yes.
So I think is a O and a stroke across it.
A O and a stroke across it. We're going to come to that O and a stroke across it in a moment. We're going to come to empty set in a moment. But if we want to say, for example, not a member of, let me just turn it around. All right, I'm hearing all of these things. We're going to come to that in a moment. Not a member of. If an element is a member of, we use the symbol which comes like this. But in mathematics, you know, we wouldn't want to be writing different symbols for everything. So we just make a slight change to this symbol. You were saying, yes, very good. We just draw a line through this. So if it is a member of, we use the symbol by itself. If it is not a member of, we draw a line through it. All right? So for example, if A is equal to the set A, B, C, well, then we can say that P is not a member of set A. All right? Can we say the same thing for K? All right, K is not a member of the set A. Good? So we can talk about we have a set, and we can talk about the elements of the set. But these here are all letters. So this is just a fraction of the set of letters. So if we're going to consider all the letters in our alphabet, when you're considering everything there is a particular name we give to that big set. The set that contains everything. It begins with U.
Universal.
Good, the universal set. The universal set is a set that contains all the elements under consideration. So this might just be a fraction of that set. And the universal set, again, this is too much to write. So we as mathematicians, you know, we have to find a short way to write the universal set. So to write the universal set, we use the symbol capital U, the universal set. So usually when we're writing set, if you want to name a set, you reserve this letter for the universal set. You do not name any other set with U except it is the universal set. All right? Good. So we might have, for example, we may have U equal to the set of letters. So then, therefore, means that A now can be found in this set. Do you agree? Yes. That A can be found in this set. But if A can be found in this set, there's a special name for that too. If one set is a part of another set, huh? Sure. Think about it. One set. Man, you give me the answer so fast. Yes, yes. All right, good. Subsets. Yes, we can talk about subsets. So, what we have is a subset. And a subset is a part of another set, right? Or we could say a set within another set, right? A subset. And if we have the symbol we use for subset is as if you have an elongated C. If you take a C and you stretch it out, right? So we use this for a subset, right? A subset being a part of another set. So again, if U is equal to the set of letters, and we have the set A being equal to A, B, C, is U a subset of A?
Yes.
Uh-huh.
No, sir. A is a subset of
A is a subset of U. I know what a catch-all there. Good. So we can see that A is a subset of U. All right? Yes, because all the elements of A can be found in U. What about this? If a set B is equal to a set of P, Q, R, 1, 2, 3. Can we say that B is a subset of U?
No, sir.
No, sir.
Why?
Because numbers is in it.
So it's like a mixture of numbers and letters.
But isn't P in U?
Yes, sir.
Yes, sir.
So we have elements from the set in U.
So we're going to take numbers 1, 2.
Yeah, as long as there's one element of this set that cannot be found in U, it means B is not a subset of U. But how do we write is not a subset of U?
Sure.
Yeah, the same slant line through it, you know. Anytime you want to say not something, just in mathematics, a quick way, just draw the line through it. So we say that B is not a subset of U. So it means there's some elements about B that cannot be found in U. Now, if we want to reverse this, sometimes we have U. We would want to speak about I know you might not have heard this one. Superset.
Yes, sir.
So you know about this? All right, good. So at least we learned some sets in grade 7. So we have the superset. Now, the superset is not necessarily the universal set, right? The superset could be some other set which contains a subset, all right? So, for example, we have U equal to letters. We have A equal to ABC. What about if we have X equal to BC?
Yes, sir.
Here we see that all the elements of X can be found in A, even though A is not the universal set. All right? So what we can write here, therefore, that X is a subset of A. But then if we want to bring A to the front, then we can say that A is a superset. Observe how we reverse the sign there?
Yes, sir.
A is a superset. This is a symbol we use for a superset. A is a superset of X. It means that, same way, all the elements of X can be found in A. So far, so good?
Yes, sir.
All right. Y'all ever hear people say math's hard? Y'all just say it yourself too, no?
No, sir.
You don't say it? Okay, good. I'm happy that you don't say it. All right. But what sometimes we might have two subsets in a universal set. Let's consider if we have two subsets in a universal set. So if we have U equal to the set of letters, in the alphabet, of course, we have A equal to the set A, B, C, and we have P equal to the set of B, A, D. Good. A and P are both subsets of letters, of this set of letters, the universal set. But what if, sometimes we're interested in combining the two? For example, look at this class. We have a set of males and we have a set of females. But when you both combine, you form the class in general. All right? Good. So if we want to combine these two, there's a special word we use when you combine.
Union.
Man, you take the word out of my mouth. Right? Union. Yes, we can speak of union set. Good. And the union set, we use the symbol very similar to the universal set. All right? But yes. Yeah, we don't have this stroke coming down back. So we use this symbol to represent union. Right. So we can say that A union B. Let us really understand what this is saying, though. It is saying all the elements of A together with all the elements of B. So you take the two sets and you combine them. Take the two separate sets and you put them into one set. As if you have two baskets with mangoes and you take both baskets and you put it into one bigger basket. All right? So union. So A union B will therefore be equal to the set of. Now, I'm going to do something here, and I want you to point out where I went wrong. All right? So look carefully. If I'm going to put these two together, well, then I'll have A, B, C, B, A, D. And I know you did sets in form 1, so you will be able to point out what I did wrong there.
Sorry, wrong.
Yes, let me hear you. Yes.
Yes, sir. It's to put 2A in 1.
2 A's listed there, or you have A listed twice.
Sir, and 2.
And the rule says that you cannot list an element twice. All right? So we take out one of the A
One of the B.
and one of the B's. Good. So let me list this back again now. So we would say that A union B is equal to the set A, B, C, D. Great? A union B equals to A, B, C, D. All right. Strange though. But y'all observe what I observe about these two sets. We have 3 elements here and 3 elements there. But we only end up with 4 elements in the union.
Because are we
It's
bring it
because they
together?
repeated to A in the
They're repeating. So A is repeating. And that's because A is across here and A is across there. B is here, B is there. So that caused me to think of something else. If A is there and A is there, so therefore means we have some elements in both sets.
like A is a complement of B.
A is, what you mean A here, this A you're talking about? Is a complement of B. All right. We can come to complement in a moment. All right? Good. Let's come to complement in a moment. Yeah, but what? Observe that A and B in both of them, so we have some elements in common. And there's a special name that we give to all those elements that find themselves on both sides. They're not over here or over there alone. They're on both sides. You know? There's a special name we give to that set. It begins with I. Think about it.
Intersection.
Let me hear it again.
Intersection.
Intersection set. Intersection set. And for the intersection set, the symbol we use is the reverse of the union set. All right? So, for example, we would say that A intersection B is equal to the set of the elements in common with A and B. And we have A is common, B is common, and nothing else is common. Good, so we can speak of this here. But somebody, you know, was running ahead just now and wanting to speak about complements. So let's go on to complements. A complement set. Now, if we have the universal set equal to, I'm going to just use letters today, equal to letters of the alphabet. And we have A equal to A, B, C. Now, there are some elements in the universal set that are not in A. Give me one example. D. Good. Another one. F. So we can identify all those elements that belong to the universal set but do not belong to this set here. And those elements we call the complement. All right? So the complement set, we denote it with, for example, A, we say A with a dash up here, and we say A complement. So we write, for example, A complement. The elements outside of A is written as A with a dash up there, A complement. All right? Good. So what will be a complement? Now here we are, you here and me. What will be the complement of students here? Wouldn't it be me?
Yes.
I will be your complement because I am not a student. So it means I am your complement. All right? We're all in the same class, but I am not a student, so it means I will be a complement of the set of students. Good. We can talk about complement. Now, what about if we have a set looking like this? R is equal to, and nothing is inside this set. Poor set.
Empty set.
Empty set. There's another word for empty too that we use in maths. Begins with N.
Not
Not, can't remember.
not a set of, not a member.
No, it's not.
All right. This set here, I'm going to give it a moment. This set here, we refer to it as the empty. The empty set. Another word we use for the empty set, we say the N-U-L-L, the null. All right, null or empty. So in future when you see the word null, no, it's referring to the empty set, right? So we can also say the null set. The empty set or the null set. Yes, we have a next one.
Yeah, next sign.
Yeah, I think somebody was mentioning it. O with a stroke through it. Yes, sometimes that symbol is used for the empty set, but the empty set is mainly denoted with this symbol, but sometimes this other symbol is used for the empty set. Can anybody give me an example of an empty set? Yes.
The set of boy with wings.
The set of boys with wings. Anyone of you in this class get wings? All right, good. So the set of boys with wings, that will be an empty set. All right? Good, because we wouldn't have any of the boys in this class with wings. So we see, today we looked at quite a few symbols in sets. We came across quite a few symbols in sets. And I'm very happy to work with you. And I look forward to our next class. However, we're going to summarize our class today. And when we meet again, we're going to take it from here and we're going to explore more mathematics. Are you excited about exploring more mathematics?
Yes, sir.
All right, good. Thank you.